Okay, so today we're going to do the study guide for the first test. We'll start with number 1, give the domain and range of the given relation. So remember, the domain is all the x values in a function relation. The range is all the y values. So the domain here is going to be -1, 2, and 5. Remember, you don't need to repeat the -1 since it shows up twice. You only have to put it once. So our domain in the answer choice needs to include all of these numbers. Okay, all 3 of these numbers. So let's look and see if we can eliminate anything. The first one has -5, okay, and it has a -1, okay, and it has a +2. So that works. The second domain has a -1 and a 0. Now, there's no 0 in the domain, so it's not B. C has -5, -1, okay, those are both good. -9, no, -9 is not in the domain. -9 is in the range, so that should not be included here. That's false answer. D says -9, 7, and 21 in the domain. None of those numbers are in the domain. The domain is the x values, so it's not D. The only answer that works is A. And A also has the correct range. The range is -9, 21, and 7. And that's what we have here. So it's A. Okay? Number 2 is which relation is not a function. For this one, I'm going to pull out my trusty highlighter. And I'm going to highlight all the x values. Remember, if any x value is repeating, then it's not a function. So let's look at the x values. This one has repeating x values, so that one is not a function. Not that one. B also has repeating x values. It has a -2 and a -2, so that's not a function. C is just the same x value repeated over and over. That's definitely not a function. And then D, 2, -7, +7, -3, and 12. None of those are repeated. Remember, this was a typo. It was supposed to be a -7. So the answer is D. Okay? Give the domain and range and determine if it is a function. So we have to do 2 things here. Give the domain and range and determine if it's a function. So let's see if it's a function first. Now remember, in a mapping diagram, you're going to be looking to see if any of the x values have double arrows. If there are any double arrows or 2 arrows coming off of the same number, then it's not a function, because that would mean that the x values are repeating. So -1 is not repeating. 0 only going with 1, not repeating, not repeating, not repeating, not repeating. So this one is a function. So yes, it is a function. That means we can rule out the ones that say it's not a function. That means A and B. So it has to be either C or D. So let's see. The domain is all the x values. So the domain here is -1, 0, 1, 2, and 3. And the answer choice with those numbers, all of those numbers in the domain, is C. D is missing a bunch of numbers from the domain. It has to be all the numbers in the domain listed in the list. Okay, the range is 3, 5, 11, and 21, and that's right too. And this is a function. Okay, number 4. There are 2 correct answers for number 4. So this one says, for which value of x is the relation here not a function? That's an important word. Not a function. So we want to make this not a function. For something to be not a function, it would have x values that are repeating, right? A function is when none of the x values repeat. So we have to see which number, if we made x one of these numbers, would it not be a function? So let's see. Let's highlight the x's first. Okay. If we made this x into a -1, the x value, -1, would be repeating, and that would make this not a function. So A is one correct answer. Also, if we made this into a +3, then we would have repeating x values of 3. And that would also not be a function because the x value would be repeating. Okay, so those are the two answers for this one. 6 and 4, there are no x values there are no other x values that are 6, and there are no other x values that are 4, so that would work. Okay? Number 5 says determine if the graph below represents a function. So on a graph, remember you have to do the vertical line test. So let's see if there's anywhere where a vertical line would touch the graph more than once. One time, one time, one time. There's nowhere that this vertical line would cross more than once, so this is a function. So we need to cross out the ones that say not a function. So the relationship is a function because it passes the vertical line test. It passes the test. Okay, number 6. Given the function -2x minus 4, evaluate to determine the value of x when f of x when x equals -3. So here you have to take your function, and you guys are so good at this. You take your function, -2x minus 4, and you use the value that they give to represent, like to substitute in for x. So we're going to do -2 times -3 minus 4. Remember to multiply first. -2 times 3 is 6. And 6 minus 4 is 2. So the answer is +2. Okay, number 7 we did do in class, but I'll just explain it again. You have to take your function, -1/2 x minus 4, and use it to, and like plug in 1, 2, 3, 4, and 5 for x in the function. So you would start off by saying, okay, let's do -1/2 times 1 minus 4, and that will give you -4.5. Then you would, so that one works. Then you do -1/2 times 2 minus 4, which is -5. Then you do -1/2 times 3 minus 4, which is -5.5. Then -1/2 times 4 minus 4. -1/2 times 5 minus 4. You just put each number in for x, and then you have to pick the table where the answers that you get match up to the numbers on the bottom, okay? Alright, for number 8, is the graph below a function? We kind of talked about this one in class a little bit, I think in 4th academic. But this graph actually does not pass the vertical line test on all these places. Right here, 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 and here. All of these spots on the graph are vertical lines. And so remember, vertical lines, like, it's going the vertical line is going to hit it more than once. Like these x values are all repeated. So this one is not a function. The function, sorry, the classroom next door is being like really loud and I can't think. The graph fails the vertical line test. That's why it's not a function, because the vertical line hits it more than once on one line. Okay, given the function table below for f of x equals 3x plus 1, determine the range of the function. So that means we have to determine the y values down here on the bottom. So we're going to use -1, 0, and 6 in our function. So we'll do 3 times -1 plus 1, 3 times 0 plus 1, and 3 times 6 plus 1. So 3 times -1 plus 1 is -2. 3 times 0 plus 1 is 1. 3 times 6 plus 1 is 19. So that is D. Okay, temperature changes throughout the hours of the day. Early in the morning, the temperature increases slowly. At noon, the temperature drops slightly. During the afternoon, the temperature stays the same for a few hours. As afternoon transitions to evening, the temperature continues to drop. Choose the graph best represents the temperature change through the day. So, in the morning, the temperature increases slowly. So we need to start off with an increase. Now, increase, 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 increase. All of those do. At noon, the temperature drops slightly. So we increase and then we drop a little bit. So the only one that increases and then the temperature drops is A. This one increases and then increases. Increases, increases. Increases, increases. A is the only one where the temperature increases and then slightly drops, and then it says afternoon the temperature stays the same. So here it stays the same. It's a flat line. And then in the afternoon goes to night, the temperature drops again. That matches best with graph A. Okay, number 11. We're going to write a function to represent this scenario. Courtney belongs to a health club that charges a monthly fee of $20 plus $85 to join. Write a function to represent her costs. Okay, so we know we're going to have to do y equals blank x plus blank. So the first thing we need to do is figure out what the rate of change is and what the initial value is. So you have to look back at the word problem. Remember, the rate of change words, you can write them right over here. The words that give you a clue that that number is the rate of change are per, each, monthly, every, daily, hourly, stuff like that. Okay, those words give you a clue that that number is going to be the rate of change. So here we have a monthly fee of $20. So $20 is our rate of change because that's the amount that she's paying every month. And then it's $85 to join. That's the initial value. That's the one-time fee. I'm making the video. Huh? Portia, I can't pause it. I'm making the video. Shout out to Portia, everyone. Portia's trying to get in the door, but I'm not going to let her. So $85 is the initial value. And so your equation is y equals 20x plus 85. So that's your equation. Then it says how much has she paid after 6 months. So we need to see, let's see, we're not doing number 12, so we'll draw it down here. We'll make a table. So Courtney at 0 months, like before she even goes to the gym the first time, she has to pay $85. That's her initial value, $0.85. Then after each month she has to pay $20. So 85 plus 20 is 105. Okay, so that's how much it is after 1 month. So 2, 3, 4. We're going to do 6 months. So we're going to add $20 to her amount every time. So 105 plus 20 is 125. Add 20 again, 145, 165, 185 for the 5th month, and then add 20 again, and you get 205 for the 6th month. So her amount goes up by $20 every month. So after 6 months, it's $205. And you could just make a table to do that. Okay, we did all of these in class for 13 and 14. Real quick, just going to do 15, 16, and 17. So an aerobics class is being offered once a week for 6 weeks. The registration fee is $15, and the cost for each class attended is $10. There's that word, each. That's your clue that this is the rate of change. That's the amount that's repeating every time. So it's y equals blank x plus blank. The rate of change is 10, because she has to keep on paying that over and over. The registration fee, she only has to pay that one time in the beginning, so that's the initial value. Okay? All right? Julia has been measuring the baby's hair. The first time it was 6 centimeters long, and after 1 month it was 2 centimeters longer. If the baby's hair continues to grow, determine a function that represents the growth. Okay. Y equals blank x plus blank. The first time it was 6 centimeters, and after 1 month it was 2 centimeters longer. Okay, so there's monthly, it grew 2 centimeters. So that's our rate of change, 2 centimeters a month. And then at first, that's the initial amount of the hair. It was 6 centimeters, so that's your initial value. Okay? Y equals blank x plus blank. When he measured his puppy's hair the first time, it was 8 centimeters long. The first time. That's your clue that this is the initial value. At the beginning, it was 8 centimeters, so that's the initial value. A month passed, it was 12 centimeters long. If the length continues to grow at this rate, determine the function that represents the length of the puppy's hair. So we have to figure out, the puppy's hair didn't grow 12 inches in 1 month. It went from being 8 centimeters to 12 centimeters. So it actually only grew 4 centimeters. It went from 8 to 12. So it went up 4. So the rate of change is actually 4 centimeters per month. So that one's 4x plus 8. You had to do an extra step there. Okay, which of the following represents a function? Let's look at the x values. None of those are repeating, so this is a function. This is not a function because 5 is repeating. This is, let's see, yes, this is a function. None of the x values are repeating. This is not a function because it fails the vertical line test here and here. This is a function because it passes the vertical line test. This is a function because none of the x values have a double arrow. None of them are repeating, so it's a function. Okay. Number 19 said Chris rented a fishing boat for a $45 initial fee plus $30 an hour. There's your initial value. There's your hourly rate. If Chris spent $190, this is supposed to be $195. How long did he rent the boat? So our equation will be here. Y equals $30 an hour. That's our rate of change. $45 initial fee. That's the initial value. Now, let's figure out how many, let's just do like process of elimination to see which one of these is right. So we know it's $30 an hour plus 45, and we know he spent this much, $195. So let's calculate it. For 10 hours at $30 an hour, that would be $30 per hour times 10 hours plus $15. Or, sorry, $45. So 30 times 10 plus 45. That's $345. That's way too much. That's not $195, so that one's not right. For the next one, we do 30 times 5 hours plus $45. 30 times 5 plus 45. That's $195. That's how much he spent So that is the correct answer. Okay, so that one's B. Okay, number 22. Which graph matches the scenario? Jackson ran to try and catch a bus at a stop almost half a mile from his house. He waited 2 minutes at the stop, but realized he had missed the bus. He turned and started walking back home. So this is the time and the distance from home. So this boy, he walked to the bus stop, waited there, or well, he ran to the bus stop, it said. He ran to the bus stop, waited there, realized he missed the bus, and then went home. So let's look at the graphs. This one, he's running to the bus stop, going up to the bus stop. Then nothing's happening, he's waiting, and then he goes back home. So this one looks pretty good to me. I'm going to say that one's probably it, but let's look at the others. In this one, he runs to the bus stop, or, well, he doesn't even make it all the way there. He runs a little bit, and then he goes back home a little bit, and then he runs again, and then he waits. So that doesn't make sense. Here, he goes to the bus stop. Good, okay. Waits, like does nothing. Runs again, and then waits again. So that one doesn't make sense either. For this one, he runs to the bus stop, waits, runs again, and waits. He never goes, this one never shows him going back home. So that one's not right, and it is the first one. Okay, last one, number 24. Given the equation y equals $12x plus 5, what is the rate of change and initial value? Remember, it's always y equals blank x plus blank. The number that's attached, like with the x, is always the rate of change. So the rate of change here is 12, and the initial value is 5. All right, as an ordered pair, we would use that 0, 5. All right, guys, make sure you study on Sunday, and see you then.